The internet is one of the greatest inventions of modern history. When I'm playing an online video game and all of a sudden my game starts to lag, the worst, but I also wonder, well, why is this happening? Is it my internet? Is it the console? And then it makes me think, how does the internet really work? I mean, we get on all these online video games and streaming services. How do we access all of these things so quickly from our devices? Can you imagine what our lives would be like without the internet today? I'm going to explain how the internet connects all of us using just light, and show you some amazing labs that can demonstrate how light can transmit information across vast distances. Welcome to LabRats. We are a nonprofit science education company. I'd like to thank Ting, our sponsors, for helping us provide high-quality science education all around San Diego County. Ting is an internet company that provides high-speed internet to San Diego Coastal, and they have provided us today with a real section of high-speed fiber optic cable. The internet was created by dozens of pioneering scientists, engineers, and computer programmers. But the internet would not have been made possible without the trailblazing efforts of Robert Kahn and Vinton Cerf in the 1970s, and also about 20 years later with computer scientist Tim Berners-Lee. In simple terms, the internet is just a bunch of computers that are all connected with cables so that they can access and share information. There are now over 1 billion computers that are all connected all around the world. They are connected either through a network of cables that are buried underground, maybe cables hung high on telephone poles, or even accessing satellites in space, or through cables that are actually laid on the bottom of the ocean. On a map, all of these cables look like a giant web. They connect each continent, country, city, and town. That's why we call it the World Wide Web. To access this wide web of physical connections, you have to go through a company. The internet is a service that must be provided. Adults pay internet service providers for access, and we connect our computers through cables or maybe through wireless Wi-Fi router at home so you can connect your computers to the internet. Computers know exactly where to access the information you're looking for by using what's called an IP address. Just like we have a home address that allows us to find where we each live, our family and friends. IP addresses are unique to each internet connection. For example, our website, sdlabrats.org, has its own IP address that allows you to access all of our science labs and videos. In order to get to the movies that we like to stream, or access the video games that we like to play online, we have to access a computer that's far away, where the content is actually physically stored. Those computers are called servers. Now, most of the content that we like to observe and consume is stored by servers. Google and all the others have these massive buildings that are out all around the world that are filled to the brim with these servers. And these servers store all of the information, the photos, videos, memes that we like to consume and create. Now let's go into detail about the science behind this web of cables that connects all of the computers to the internet. Now, it wasn't too long ago that if we wanted to connect to the internet, you'd have to call in, and it'd take over 10 minutes just to connect. If you wanted to download just a single picture, it could take over an hour. We used to get internet on CDs found in cereal boxes. I don't really believe that. With the advancements in technology, both in the computers and the wires that connect them, we now can stream videos in 4K, play video games like Fortnite or Warzone with friends that are anywhere in the world almost instantly. Back in the day, if you wanted to play a video game with your friends, you'd have to bring your entire Xbox or console with you and play the game in the same room, connecting them with a wire. We called it a LAN party. Ask your most technologically savvy guardian to show you where your internet router is. You will find wires that connect to your internet router, that connect to your computer. Maybe it goes into or out of the wall. These wires are made up of copper that are encased in a plastic coating. Now, copper is an incredibly useful material. It's both able to send the electricity throughout our homes, but it also allows us to connect and send information for our computers. But copper has some problems, and this has led us to a newer, better and faster option. Fiber optic cables use newer technology that is more widely available than ever before. For internet cables, fiber optic is ideal because it's not only hyper efficient, the cables are also more durable, and it allows us to connect with all this information with the fastest thing in the universe: light. Fiber optic wires use light to send all the information all around the world. But let's think about it. How? How can we actually send information using light? Let me show you. Now, with a simple laser pointer, we can send light very, very far distances, but it only travels in a straight line. Unfortunately, things get in our way and block the light. Earth is a sphere, and my light signal will just shoot off into space. It won't bend around the curvature. So we need to be able to bend this light so we can connect every house and every country all around the world. Scientists figured out that by shooting a laser beam of light into a glass or plastic tube, that the light will actually bounce back and forth through this wire, even through the curves, and it'll still come out the other end. This is how fiber optic cables work. This is a real section of fiber optic cable that was given to me by Ting Internet. They bury this underground. When your computer accesses the internet and wants to get some information, this information is transmitted through these cables. Then it's translated by your computer. Your computer takes in this code, and that's the code that allows you to operate a program or watch a video or photos or memes. This first demonstration I have here is a curved acrylic tube. Using a green laser pointer, you can see how the laser travels through this tube, and it goes all the way through and out the other side. As I start changing the angle, notice how the light bends and reflects off the walls. This is called total internal reflection, and it forms a nice wave function, like a sine wave, bouncing through the whole tube. For your first experiment, you're going to need a Sharpie, a note card, a clear glass or plastic cup, and some water. Draw a nice big arrow on the 3x5 card. Place it above the cup and then slowly lower it behind the cup. Now it has to be a few inches behind for this to work properly. As it goes down, notice how the arrow switches. This is because light bends through different materials. So going from the air to the glass, through the water, through the other side of the glass, back into the air, the light actually turns. For this last experiment, all you're gonna need is a 2-liter bottle, a laser pointer, water, and some kind of basin bin or sink so the water can safely go into and you won't make a big mess. Cut a very small hole in one side of the 2-liter bottle. Use a piece of tape to close up the hole and fill the bottle full of water. Use your laser pointer to shine your light through the bottle into the hole. Removing the piece of tape, notice how the water spills out in a nice curve. The laser will actually, if you're pointed at the hole, the laser will actually bounce inside and travel with the stream of water, bending the laser pointer. Turn off your lights to see this better. And when I put my hand in front of the water path, the laser is right there. If I move the laser up above the hole, it'll still come out straight. And I can show this with some Febreze so you can see this straight laser. But once you move it back into the path of the water, it is curving. It is internally reflecting inside the water. Now, these were large-scale experiments about how we can bend light, but if we want to send information accurately and very quickly, we need to be able to do this much more efficiently. So when you look at the real fiber optic cable, notice how small these wires are. Each individual fiber optic cable is about the width of a human hair. So small that I have to look at it under a microscope. We have improved our technological capabilities so far that we can now control light to be very, very small lasers. So we can shine our light through these very small cables and send that information incredibly fast. Now there's multiple ways that we can send information using light, either by simply turning it on and off. That's a form of computer code or binary, on, off, 1, 0. Or we can try to manipulate the light by changing the frequency or the amplitude. That's how FM or AM radio are different: frequency modulation and amplitude modulation. Using these techniques, we can then send massive amounts of information incredibly fast and accurately to each computer. So when we're at home surfing the web, we can access the information that we want almost instantly. By understanding how light behaves when it goes through different materials, we have created incredible fiber optic cables that allow us to access the internet at incredible speeds. Have fun exploring how light interacts with different materials. As we better understand how the world works around us, we have the power to change it. Happy sciencing!